right. Quiet, please. Time to finish up. 4.5, number 2. We're doing natural log functions. Oh, we're doing log functions. Oh, we're doing log functions. All right. Quiet, please. If P denotes the selling price in dollars of a commodity and X is the corresponding demand and number sold per day, then the relationship between P and X is given as this. Now, E. Does anybody remember the decimal for E? 2.718, something like that? Well, that is obviously greater than 1.
Would all SMCA numbers and FFA numbers come down to margins or pictures and still send them to the cheerleaders for change?
Okay. Now, when you do this problem, E is a number, not a variable. Yes? Similar, approximately. Anyway, where it says express P or express X as a function of P, that means you have to get X all by itself. P is your variable. So if P is a variable, that means this is a constant and the A is a constant because it's expressed as a function of P. So basically all you're doing is solving for X. Computer programmers do this all the time. When you're writing a program to solve certain things or figure out certain things, you solve the equation once and then the person running the program puts in all the information to get the answer. So, P equals P sub 0, E to the A. I think there's a negative up there. So, first things first. Oh, yeah, divide by the constant P sub 0. And when you do that, you're actually almost done. This is exponential form you want to rewrite as a log, correct? And this log has base what? E. So, log base E of P divided by P sub 0 equals negative A to the X. Now, depending on the directions, it depends on how you finish writing your answer. In this case, the directions say, I want to express X as a function of P. So once you get X by itself, you're obviously done. So you can divide by negative A. X equals log or natural log. Natural log of P divided by P sub 0 divided by negative A. Okay. And that's about it. You could write your answer a lot of different ways. It's ln because you have log base E. And also this 1 over negative A. Remember, based on our log laws, you can write that as an exponent. So if you want to keep going with this answer, you could write natural log of P divided by P sub 0 of 1 over negative A. You could do that. You could also write as natural log of P divided by P sub 0. Sorry, P sub 0 over P. So there's lots of ways to write the answer once you get in this form. Usually you just kind of pick one and you stop. But there's all kinds of ways of writing it. You can also subtract them if you like. All right. So I think I just answered the question on that one. Here we go. This is a half-life problem written a different way. How many years would it take to clear 50% of the pollutants? They give you the constant, K. Some books use K, some use C. The business equations use R. With the K in front of the T. So how would you set this up if you were looking for a half-life? Yeah, you can plug in 50% for Y because that's how long you want to end up with. Remember, this is the original amount, Y sub 0, and this is the ending amount. So if you start out with 1, you end up with 50% of it. I always start out with just a half. equals 1 e to negative 0.3821t. I always start with a half. I don't know why, just because. And now you solve for t, and there's lots of ways of doing it. Before we did logarithms, you solve for t by graphing. Now that we have logarithms, you can solve for t by basically getting exact value. Since this number is written as decimals, your answer is probably going to be in decimals also. So, I don't know, log base e of 1/2 equals negative 0.3821t. You divide both sides. Negative 0.3821, negative 0.3821. And my calculator's not booted up. I'll boot it up though. Somebody always moves it, just for fun, I think. What'd you get when you punched that out? 1.8? 0.18? That's it? That's not very long. Second and quit. Clear. Natural log of 0.5 divided by negative 0.3821. Delete. Yeah, as it was in years?
Yeah.
After how many years? So it'd be 1.8140 years. Okay, I just matched the 4 decimals that were in the problem. Yeah, half-life problems are nifty. I like those. Obviously, those will probably be on your test. That's going to be next week, apparently. Today's what, Wednesday? I think your exam is set for Tuesday or Wednesday of next week. Yeah, and then your final exam is the following Tuesday or Wednesday after that. Nice, test best. Study guide? No, not yet. I'm going to try my hardest. I'm going to try my hardest, yes. Yeah, I'll see if I can write a practice test. Yes, Miss Ballard? Probably. This semester looks like it's all going to be multiple choice. Next semester won't be. Anyway, graph them out on the same plane and estimate where they are going to solve. And we've talked about this. 3 to negative 0.5x greater than or equal to log of x. Some people are very adamant about graphing this equation. I think of it as, do I want to work with positive numbers or do I want to work with negative numbers? And that's about it. I like to work with positive numbers. So I'm going to take everything to the left side. 3 to the negative 0.5x minus log of x. If you got the calculators, then I would just use them. And I'm looking for everything that is going to equal 0. So I'm looking for all the x-intercepts. I'm also looking for all the y values above the x-axis. Above the x-axis. Because it says, essentially, where is y positive and where does y equal 0. With logarithms, I don't really have a basic idea of where it's going to happen. So I pretty much just look positive values. Remember, g of x has what domain before I graph it? Domain has to be what? Yeah, it has to be greater than 0. So it has to be positive. So I don't know if it's going to influence your graph or not, but it's going to influence mine. 3 caret negative 0.5x. Close it off. Forgot to open it in the first place. Second, insert, left hand. Minus log of x. There we go. And on my window, since I don't know, I'll probably go like 0 to 10 just to see what happens and maybe go from there. For the y's, I don't really have to look much. So on these problems, I don't really set them equal to each other and look for intersections. I look for positive numbers and zeros. I think that's the best way of doing it. So there's some positive. There's a 0. Are you going to go back up or are you going to go down? Yeah. You think it's going to stay down there? Oh, no. It's hard to tell. I'll extend my window just a little bit to 50. That's not very far. 5. There's one place it crosses. I don't think it's coming back up, do you? All right, just find it. Second, calculate 0. 0 to 10. Actually, I'll go 0 to 20. My guess is 10. These things really make math easy. 2.02.
Mr. Brand, what did your calculator look like when you were doing this stuff?
I don't know, maybe it was wrong. I did the, you mean the x minimum and the x maximum? Or the equation?
I don't know, what did your calculator look like when you were doing trig, when you were like really young, you know?
Oh, it had 9-volt batteries, and you could punch in a number, and it'd sit there and twirl, zzz, and then it would come out with an answer. And it had like 5 functions. That was it, I think. Yeah, we had to look up all the trig ratios on tables and stuff. Or slide rules. I didn't use slide rules. Some people did. 0, it's based on proportions. 0 to 2.08. So that's what x would be. Any values between 0 and 2.08. Oh yeah, you had to carry your trig tables. You had to carry your sine tables with you in your book. You had to reference them, charts.
Do you have those in your calculator?
Yeah, if you press the sign of 30, you get a decimal. Those decimals were all printed on a piece of paper. You didn't need batteries, though. Tests were a lot easier. Questions are a lot harder, though. All right. I think how much time we got left? We're almost done, aren't we? That's the last one? Are you sure? Yes, it is.
Number 64.
This one is.
We can break this up this one.
Yeah. I think you guys can do this one, can't you? Oh, the only thing is, this is like this happens in the calculus book all the time. This isn't the point 0, 3. This is the domain 0 to 3. So it tells you how to set up your calculator to find the answer. So your minimum is 0, your maximum is 3, and all your points are in between. And you can see you're looking for 0. And I don't think I'm going to go through that. What time is it? We got 10 minutes? 15? Perfect! What page is 6.2? How you doing? Oh yeah, 4.2. 3? 7? Somebody said 8. 3? Page what?
99.
Have we done 4.2 yet? One time I duplicated it. We're on 4.5?
I don't know what we've done. I don't think we've done. Do you have our last 10 hours?
I do! I have your last 7 or 10. It was on it was on page 288.
We're on 4.21.
Yeah, I said 4.2. I got a nasty look from somebody. Yeah?
So that question was just plug in a page into the calculator.
Yep. Plug it in and graph it. Oh, this is fun. All right. I don't know, I need some inspiration for the numbers.
1 through.
No, I need some inspiration. Remember, we're trying to get the most out of everybody at the least. Let's see. Let's go with the uniform number. Have you ever had? What was your last number on your little tag that you rip off when you get to the end?
Like in the
I don't know.
thousands.
Thousands and thousands.
The last number on it.
I don't know.
You don't know your number?
I was 1990. Yeah, you were 1993. I was 1993.
1993. Nice. Nines will be the inspirations. 9, 18, 27, 36. Oh, wow. How about a 1? No, not a 1. That's a dud. That's a dud. No, I take it back. I take it back. No, take it back. There's no proof.
No, it's good.
I want to do these 4. Elizabeth, what's your number? Oh, that would be perfect. You want to do 21?
Wait, it's an odd, so it's good. It's an odd.
And 21. Oh, that was a little from Alex. Nice, Alex. It was.